Welcome to my homework rewards. Today we're going to work on a vector question that involves the standard basis vectors. This is from 12.2. We're going to work on question number 21 from Calculus, Early Transcendentals, 7th edition by Stewart. I will also post the solution to question 20 online at MyHomeworkRewards.com. So the question asks us to find a number of different quantities, some of which are magnitudes, these ones here. So our game plan for solving this is first we will calculate these quantities a plus b, 2a plus 3b, and a minus b using vector addition, subtraction, and scalar multiplication using the standard basis vectors. And then next we will calculate the magnitude for these two quantities here. So looking at vectors a and b, they're expressed using the standard basis vectors. These are just vectors that run along the x, y, and z axes and have a magnitude of 1. So another way to write vector a in this notation is just 1, 2, minus 3. And vector b is minus 2, minus 1, and 5. So it doesn't really matter which notation we use to solve them, but we'll use the standard basis. So for the first one, a plus b is equal to I plus 2j minus 3k plus minus 2I minus j plus 5k. Now to add these, what we want to do is we want to add basically collect the like terms. Add the i's together, add the j's, and add the k's. So 1i minus 2i is negative I. Then we have 2j minus j, which is a positive j. And negative 3k plus 5k is 2k. So this gives us the quantity a plus b, and again you can also write this as a minus 1, a 1, and a 2. So it just represents a vector that has a magnitude of minus 1 in the x direction, 1 in the j, and 2 in the k. So you can pause the video here and try to calculate the quantity 2a plus 3b. So next we're going to calculate the quantity 2a plus 3b. So we have 2 times vector a, which was I, plus 2j minus 3k, and plus 3b, which was minus 2i minus 1j and 5k. So again, we'll add the like terms, but first what we'll do is we will apply the scalar multiples 2 and 3. So to apply the scalar multiple of 2, we just want to multiply it in, distribute it in to each of the terms. So that gives us 2i plus 4j minus 6k. And for the 3, we'll get a minus 6i b is minus j, so minus 3j rather, and plus 15k. So now we can collect the like terms here. We have a 2i and a minus 6i. That gives us minus 4i. We have a 4j minus 3j, just gives us a positive j. And we have negative 6. Clean that up. That's a negative 6 plus 15k, which gives us 9k. Lastly, we'll also calculate the quantity a minus b, which we'll need to calculate the magnitude of that vector. So for a minus b, we have I plus 2j minus 3k, and then we have negative b, so we have minus negative 2i minus j plus 5k. So we can also distribute that negative sign, so the a stays the same, but now we have a plus 2i plus j and minus 5k. We will collect like terms again. That gives us 3i plus 3j and minus 5k. So far we've calculated a bunch of quantities. The first one was a plus b. The second one was 2a plus 3b, which is over here. And lastly, we have a minus b. But the question asks us for the magnitude of a minus b, so we'll get to that. First, we want to calculate the magnitude of a. Recall that to calculate the magnitude of a vector, we just take the sum of squares of each of the terms. So for a, we just have a 1, which was on the I. We have a 2 on the j. And we have a minus 3 on the k. And this just equals square root of 14. And then the magnitude of a minus b. Give this one a shot. Remember, we want the sum of squares of the x, y, and z components. So recall when we did a minus b, we ended up with a 3 over here, 3, and a minus 5. And this gives us the square root of 82. We can try to simplify these radicals, but it doesn't look like you can. So our answer is for square root, or for the magnitude of a and the magnitude of a minus b. So to recap, for this question, we were asked to calculate a number of quantities using vectors a and b, which were expressed as in terms of the standard basis vectors. Standard basis vectors is just another notation that we can use. Otherwise, we could have just used this more standard notation with the x, y, and z components. So we used algebraic vectors, addition, subtraction, and scalar multiplication to find the various terms. And then to calculate the magnitudes, we use the sum of squares of each of the the components, the x, y, and z directions. Hope this video was helpful. Remember, you can check out MyHomeworkRewards to review lessons, watch other video solutions to questions, and also practice more vector questions using our adaptive learning system. As you answer questions, it learns about your strengths and weaknesses and tailors the questions to best suit your goals. Also, you can earn rewards along the way from top brands such as Bench, Adidas, Columbia, and Ardeen. Have a good one.